Bicycles have been around since the 1870s. They were used as the main form of transportation before carriages and automobiles overtook the roads in the US. It is estimated that about 112 million Americans rode a bike at least once in 2024, according to People for Bikes. In the city of Atlanta, Georgia, there are currently multiple initiatives to increase bike accessibility, such as creating new protected bike lanes, unlike those on Juniper Street and Piedmont Avenue, as well as increasing access to the Beltline where people famously enjoy taking a ride through the city of Atlanta. One of the main current markets for bicycles is the share fleet system with organizations like Lime and Bird. Both cater to the average pedestrian to be able to quickly rent a bike and use it as a temporary means to get around the city or enjoy the scenery. One existing issue is that their bike system is a one size fits all. This often means that riders who do not fit the average size often experience discomfort. While the saddle can be adjusted manually, the handlebars cannot, and so often it is inconvenient for the rider who wants a fast solution to change the settings. This often leads to riders using the default settings despite how uncomfortable it can be. Riders who travel in this discomfort often experience fatigue, knee, and or back strain. In the long term, they can also develop other health effects if they often use these share bikes as their main mode of transportation. Currently in the market, there are companies like Retool who use 3D motion capture and biomechanical analysis to evaluate position within millimeter precision. These are usually professional bike fitting services and aren't used by the everyday user since they are extremely expensive. Therefore, our team, the Jiao Jokers, aim to bridge the gap between riders and one-size-fits-all shared bicycles by re-innovating the standard bicycle through our product, Ridefit. We, the Jiao Jokers at Georgia Tech, are creating a new way for companies to manufacture bikes so that the saddle and the handle mechanism of the bike are motorized. Not only that, but we are innovating a way to measure the rider's measurements from a camera, and from this, we are getting the data that communicates with the bike and it adjusts the bicycle's saddle and handlebars automatically so that these new manufactured bicycles can automatically adjust for the user. Ridefit allows you to have technical knowledge to adjust the bike and want an affordable solution to be able to ride a bike that fits them ergonomically without the extra hassle. With this product, they can simply walk up to the kiosk, get their measurements from a camera that scans them, and that data is relayed to the bike, and immediately they're able to get an adjusted bike that they can ride comfortably. It helps long term bike users enjoy the ride and it will lead to higher customer satisfaction and more long term users that can enjoy the ride in their customized bicycle. Since no current existing businesses cater to this need for the masses, and there are only businesses that do these services for individuals at a great expense, we are also bridging the gap so that companies are able to manufacture bicycles that are ergonomically and truly accommodating for anyone to use of any size. To quantitatively prove that designs meet the required structural and safety factors, calculations were done on the handlebars treated as a beam to account for the twist, bending, and other stresses. Calculations were also done to figure out the necessary motor that is able to handle both the load and have enough input force to move the lead screw. For the saddle component, another force body static diagram was also made to account for the axial, bending, and other stresses assumed with an assumed 300-pound load. More calculations were also done so that the motor selected we were to also handle the load and move the lead screw. To further quantify and verify the load and stresses that the bike experiences, a strain gauge test was conducted on the beam of the bike with three different Wheatstone bridges, and an oscillator was placed to account for the dynamic load. This data was processed over a 10-minute period of time riding the bike in order to estimate the shock loads that the bike experiences in different axes. A welding test was also conducted with wishbones to test the strength of the components after welded to the bike, since this is the primary way that the components will be attached to the frame of the bicycle. It was found that some welded wishbones were stronger than non-welded ones, but it should also be noted that this may also be due to the small sample size done for the analysis. Since bikes are primarily for outside use, we also needed to ensure that the bike's components could endure outside conditions. To take this into account, and primarily to protect the electronics in the saddle, an O-ring was installed to seal the tubes of the bike and protect the motor. As for the scanning algorithm program, multiple tests were conducted to ensure that the program is able to accurately measure data from the user based on a scan from a camera. The connection from the program and the motors was also tested via a direct cable for prototyping purposes. but post manufacturing communication between the program and the bike will likely be through a Bluetooth connection. For future work, more analysis in depth will be done and further tests will be conducted, and specifically more tests in dynamic loads will be done to prove that this prototype is both safe and ergonomically possible. We, the Jiao Jokers, look forward to showcasing our products to show how we prototype, improve, tested, verified, and manufacture Ridefit at the Summer Capstone of 2026 at Georgia Tech. Thank you for listening.